Hey guys, Mr. Jenkins back here with technically the 5th lesson in Chapter 6, but really the first lesson of our next unit, right? The next test will be over sections 6.5 through 6.8. So we're treating this as its own kind of standalone unit. And this lesson covers how to solve radical equations or equations involving exponents, right? Because we learned back in lesson 6.4 how to, basically that, something that's written in radical form can also be written in exponential form. So just a quick review of that, if we had the third root of x squared, how that would be equal to x to the power of, that would be my numerator, that would be my denominator, so x to the power of 2/3. So we use a lot of that in this lesson, okay? And it says here, anytime that you have a variable under a radical sign, you may have to use exponents to solve. And here's a nice handy list. And then notice that that last one is check your answers, because we can solve correctly and then get answers that are not, that are called extraneous solutions. So you always want to check for that. So on that note, we'll go ahead and jump right in and see what we can learn about this stuff. So the first thing you'd want to do on number 1 is isolate the radical, expression, right? So we want to move that -5 to the other side. So we're going to go square root of 4x minus 1 is equal to 5. Okay, and then if it's just straightforward, like it's a square root, if you want to undo a square root, the inverse of that would be to square both sides. And we could write this as the quantity 4x minus 1 to the power of 1 over 2. And then we would still know it's a square both sides, but I think it's easiest here just to think of squaring and square root as inverses of each other. Hello? Yes? Hey? Oh, we can't? I thought I left it open till tomorrow. I must have said it wrong. I'll fix it. No problem. Bye. Tomorrow at 11:40. All right, so after we square both sides, what we end up with is this square just undoes the radical, right? Square is the inverse of square root, so it just leaves me with what's underneath. So 4x minus 1 is equal to whatever we get on the other side, 25. And, we don't do the plus or minus there, right? Because that's just when you take the square root, all right? When you square both sides, you don't get that plus or minus thing, so don't make that mistake. Now we just have a linear equation to solve, which should be easy. So when I add 1 to both sides, I get 4x equals 26, which gives me x equals 26 over 4, which reduces to 13 over 2. All right, so at that point, I will just sub it into my original equation and make sure that it works. Okay, so that's why I have my calculator pulled up here. So second square root, and then 4 times 13 over 2. And remember, you do have that fraction button you can use if you prefer. Then arrow out, do -5. And I must have typed that in wrong. So let me try that again. So second square root, and then 4 times. And then let's try the fraction button, see if that works out a little better. So that's alpha y equals option 1, and then 13 over 2. I think I didn't do the -1. That's what I did wrong actually up there. Yeah, I forgot the -1. I think it would have worked. Now I arrow out and do -5 on the outside. And there we see it's 0. So that confirms that it works. So at that point, I know that is my solution. Okay. I'm going to leave number 2 for you. Actually, you know what? Let me skip. Let me do number 2. I was going to skip that one, but let me do that one since that one has fraction exponents, so we can see one with a little bit of a different look. Okay, so you want to approach this the same way, and you could also, if you prefer, rewrite as the square root of the quantity x plus 1 plus 8 equals 15, and you could attack it that way. Okay, but I'm going to leave it as is. So just like we'd want to isolate the radical term, we want to isolate, the term with the exponent here. So -8 to both sides is my first move. That leaves me with the quantity x plus 1 to the power of 1/2 is equal to 15 minus 8 is 7. All right, if I want to, so basically what I want is x plus 1 to the first power, right? So how can I turn 1/2 into a 1? That would be to multiply it by 2. So that means I would raise everything to the second power. And again, notice how I would have done the same thing if I would have rewritten it there, right? But again, I do that here because 1/2 times 2, which is my exponent rule there, is equal to 1. Okay, so x plus 1 to the first power is just x plus 1. 7 squared is 49. Do -1 to both sides, and we get x equals 48. And before I box it in, I will just confirm that that works. Okay, so it's the quantity x plus 1. So I'll just do 48 plus 1 in parentheses. Raised to the 1/2 power. I'm just going to do 0.5 there to save time. And then plus 8. And what we want to see there is 15. And that's what we see. So at that point, we know that solution does work. Okay. Then let's do maybe number 4. And then I'll probably... we'll do 4 and 5, and then we'll go to the other side. All right, so rolling right along. Here we go. So want to isolate the radical, and this is kind of hard to see, but it says 3 times the 5th root of x plus 1, and then plus 1 equals 7. Okay. So when it comes to isolating this, you almost want to treat the radical just like you would a variable. Right, so on a regular 2-step equation, say 3x plus 1 equals 7, we'd move that over first and then divide by the coefficient. That's the same thing you want to do here, okay? So 3 5th roots of x plus 1 is equal to 7 minus 1 is 6. Now we want to divide both sides by 3, and that would give me the 5th root of x plus 1 is equal to 6 over 3 is 2. All right, now to get rid of a square root, I square both sides. To get rid of a 5th root, I'm going to take both sides to the 5th power, right? That would be the inverse of the 5th root. And I don't really need to put the parentheses there. Not sure why I keep doing that. But anyways, what that's going to leave me with is x plus 1 is equal to whatever 2 to the 5th power is. I just punched that in, but it's 32. And then now we have a simple 1-step equation, which yields x equals 31. Last thing we want to do before we finalize is just make sure that it works. So I'll type it in just like I see it, which is going to be kind of difficult. So I want to do 3 times, and then I'm going to type 5 as my root. I think I'm typing this in right. So this would be Good for both of us to see. And then math, and then you want x root. That's the fifth option. So yeah, that's how you wanted to type it. So I did 3 times 5, and then x root, and that gave me a fifth root. Okay. Under the radical, I have x plus 1. We think x is equal to 31, so let's go 31 plus 1. Arrow out, add 1 outside, and we want to see that that's 7. It is. So at that point, we know our answer is, in fact, correct. Okay, then I wanted to show you 5, just a quick thing on 5. So kind of similar here where we want to isolate this. So do minus 10 to both sides first. That would give me 2 square roots of x plus 2 equals 4 minus 10 is negative 6. Divide by 2, we get square root of x plus 2 equals negative 6 over 2 is negative 3. Okay, now at that point, you kind of know, or if you think about this, there's no number that would have a negative square root. Okay, we're not dealing in imaginary numbers right now. So, so you might see it here that this has no real solutions. If not, you keep going, and then you get, if you see it here, fine. If not, then you'd square both sides. You'd get x plus 2 equals 9, and x equals 7. And then that's where plugging it in, is important, right? So if I plug in 7, I get 2 square roots of 7 plus 2 is 9. I'll just type that, and then add 10. So what we get is 16. What we wanted to get was 4, right? So you could also catch that this is an extraneous solution there, and that there are no real solutions. Okay. The ones that I left blank are filled out on the notes if you want to see those examples worked out. Okay. So moving on to the back side, I'll just do a few more. Once you get the hang of this thing, it's all it's all. You just get those fundamental skills. Anyways, let's go ahead and do 7 and 8, and then that'll maybe wrap us up. Okay. All right. So looking at 7. All right. So this could be written as 3. This is important. Could be written as 3 times the cube root of the quantity x plus 1 squared equals 12. Okay, if we wanted to tackle it that way, we would divide both sides by 3 to isolate this. Okay, and then, you might try to take the cube root, but then you're going to end up with something nasty. So probably better just to stick with this. All right, so let's stick with that. Okay, we still want to isolate the exponential part first, just like we would the radical part. So divide both sides by 3 first. That gives me x plus 1 raised to the power of 2/3 equal to 12 over 3 is 4. Okay, at this point, again, you're thinking multiplicative inverse, right? So 2/3 times what equals 1? Then you just do the reciprocal, right? So that tells me I want to raise everything to the power of 3 over 2. Okay, so on the left side, if I've done everything correctly, we want to end up with x plus 1. On the right side, we get whatever we get. Okay, if you could do that mentally, that's fine. That's the square root of 4 is 2, and then 2 to the 3rd power is 8. But you could also just type it in, right? 4, and then exponent 3 over 2 gives me 8, right? So you can just punch that in since there are no variables involved. So we get x plus 1 equals 8, and then that yields us x equals 7. Okay, and then we just sub in to see if it works. So going back to the top, 3 parentheses, quantity 7 plus 1 raised to the power of 2/3. So caret key 2 over 3 equals 12. That's what we wanted. So at that point, we know for a fact we've solved it correctly. Okay, then there's one more kind of special type, I guess, number 8. Notice that it's different because we have a variable on the other side. Okay, so I'll show that, and then that'll kind of just wrap us up for the notes. Then there are some on the bottom that you could try. Okay. All right. So we want to isolate the exponent first. So do -3 to both sides. That gives me the square root of 5x minus 1 equals, and then just x take away 3, right? X and -3 aren't like terms, so we just have to write it that way. Now, watch what happens when we square both sides, right? So we're going to square both sides to undo the square root. And so what happens when we square a binomial, right, is we're going to end up with a quadratic, okay? So the left side's pretty simple. Just get 5x minus 1. The right side, you just take x minus 3 times x minus 3. That would give me x squared minus 6x plus 9. All right, and then from there, you just solve this like you would any quadratic equation, okay? So we're going to want to write it in standard form. So minus 5x to both sides is going to give me x squared and then minus 11x. And then I do plus 1 to move that over, so I'd get plus 10. If you don't know, if you're not good at factoring, then you probably go into, complete the square, quadratic formula. Factoring is going to be your best bet, though. So you're thinking what's going to multiply to be 10, add to negative 11. That'd be negative 10, negative 1. So that helps you factor this to x minus 1 times x minus 10. From there, we use the zero product property. We can use these linear factors, set them equal to 0. X minus 1 equals 0 gives me the factor x equals 1. X minus 10 equals 0 gives me x equals 10. All right, so now we need to check, especially on these, right? So let's sub in 1 and see what we get. So going back to the top, we want to do square root of 5 times x minus 1. So that'd be 5 times 1 minus 1. And then go out, add 3. And then that's equal to 5. All right, remember this is supposed to be equal to x, right? So this side should have been 1. So at that point, we know that either we've made a mistake or this is what we call an extraneous solution, extraneous, okay? Which means we might have solved correctly, but it doesn't work, okay? So x doesn't equal 1 for this equation, so let's check the 10. All right, so second square root, that'd be 5 times 10 minus 1 under the radical. Arrow out, and then add 3, see what we get. All right, so we get 10. So that would tell me that when I plug in 10 on the left side, I get 10 on the right side. So at that point, I've confirmed that solution. And so x minus 10 is my one solution. All right, so you see where checking those solutions is important. Don't just assume that you've done the right work and it works, because sometimes we get those extraneous solutions, okay? So that's important. Don't forget that step. And that's all I got. So as always, this will be accompanied by a Math Excel assignment, and let me know what kinds of questions you have. Hope this helps. You all have a good one.